Let's just talk about cubed roots today. And at the start here, you have this warm-up, and I would like you to pause the video and try to determine which of these are true and which are false. Go ahead and pause your video now. Okay, welcome back. So if you notice, if you're not sure, and you see this radical symbol, and this usually means taking the square root. But when there's another number up here, it's telling us that we are taking a different root, like cubed root. And so the cubed root is saying what number times itself 3 times gives you that answer. In other words, if I had 8 in here, then that would mean that what number multiplied by itself 3 times equals 8. And that would be 2, because 2 times 2 times 2 times 2 is 8. So when you have this 3 here, it's saying we're taking the cubed root, and when you have a 3 out here, it says that we're cubing something, so they cancel each other out. So this is true. If I take the cubed root of 5 and then I cube it, my answer is just 5. Same thing for here. If they take the cube, I have the cubed root of 10 and then I cube it, well, the answer would not be 1,000, but would be just 10. So this one's false. This one here is also false, because the cubed root of 27 would be 3, but then I'm cubing it, and so the answer is just 27. This one's a little tricky, because this is asking us, well, what number times itself 3 times would give you 64? And then over here, it's saying we're going to multiply 2 times itself 3 times. Well, 2 to the 3rd power is 2 times 2 times 2, which is 8. But is it also true that if I multiply 8 times itself 3 times, would I get 64? No. The cubed root of 64 is 4. 4 times itself 4 times. 3 times would be actually 64. So these are not equal. And then over here, this is true because what's inside the radical matches the outside, and we undid the thing. So this one is okay. So yes, and the other ones are false, false, false. So what is a cubed root? So a cubed root is shown here as taking the cubed root of 64 equals 4. And why? Because 4 times 4 times 4 equals 64. So it's just like the next step after square root. And just like square root is related to squares, cubed root is related to cubes. So what it means, why we call it a cubed root, is because it is involved in finding the volume of a cube. For example, here is actually in your packet also. It has these different things. It says find the lengths of cubes with volumes of these numbers. So let's start with 27. So it's like if the volume of this cube was 27, well, to find the volume, you would multiply the, well, I'll say side, even though it's edge, but side times side again. That's how you would find, because the volume of a rectangular prism is the area of the base, the length times the width, times the height of the prism. So side, but that would be the same number, right? Side times side times side. So if I had this and I'm saying that if I multiply these 3 dimensions and the answer is 27, what would that number have to be? And that would have to be 3, right? Because 3 times 3 times 3 is 27. So if it was 27, the answer would be 3. So then what about if it was 1? Well, that would be 1, right? Because 1 times 1 times 1 is 1. So this one would be 1. And then 64 goes back to the previous slide. Well, we know that the cubic root of 64 is 4, because that one's that one. And then I can only imagine, what would the next one be? Well, let's guess the next number, right? 5. Well, what's 5? If I put 5 here, times 5, which is 25, times 5 again Well, 25 times 5 is 125. So you can see with cube numbers, it gets bigger really fast. So now that we know that, we can now apply. What we're really doing is we are asking the same question here. This is the same question as it above. It's like, if I know the volume, how do I find the side length? Well, I take the cubed root. So these are the same answers as we did with the square, or the cube, I'm sorry. And the reason why is because I'm asking myself, what number times itself 3 times equals 1? Well, 1 times 1 times 1 is 1, so that's why that's the answer. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So that's how that works. So this way, let's try this in the reverse. It says, let's imagine we have a cube that has the edge length of 5 units. What would the volume be? Well, it seems like a backwards question because I feel like we already talked about this, right? That's how we figured out the other one. They all go together. So if all the side lengths are 5, to find the volume, we would do 5 times 5 times 5. I'm after school today, and this is the noise you hear. So 5 times 5 times 5 is 125. So the answer would be 125 units cubed, not squared, but cubed. It's a third power. What about if it was 2.5 units? Well, now I have this one. Maybe I don't know this one. Now I have to multiply. So I did 2.5 times 2.5. That got me 6.25. But then I'm still multiplying by 2 by 5 again. So that is 15.625. Oops. I'll write 15.625. So now let's transition away from cubes and just look at this in a more abstract way. So let's say I have an unknown number and I'm taking the cube root of it. And I know the answer is 5. So how would I find this number? Well, to undo a cubed root, I would cube it. I would take it to the third power. Whatever I do to one side, I do to the other. So if I know the cubed root, if I cube the cubed root, my answer is just x, because it undoes that, equals 125. There's that number again, 125. We must really like it. And over here now, if I do this, if I want to get rid of the cubed root, I'm going to cube it. So I'm going to raise to the third power to get rid of that radical. And the same thing here, and we just did this problem. It's 15.625. So it's the same thing. That's a 25. Boom. So all it's really saying is, from these two questions, is the question before and the wording about finding the side, finding the volume, is the same thing as cubing it. So you can try these problems on your own and then check your answer later. But let's just look at one more aspect of this situation, and that's estimating. So we're going to estimate the same way that we did with the squares. We are going to consider any perfect cubes that we know, and I know that, I know 1 cubed is 1, and 2 cubed is 8, and 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and I'll give you 6 cubed is 216. And then I'm going to consider which of these, what's this number between? So 5 is between the cubic root of 1 and the cubic root of 8. So that would go inside here. So that means it must be between 1, try and write this, and 2. That's really messy. Let me jump over here to number 3. So number 3, okay, I have the cubic root of 81. So I look at my perfect cubes and I'm going to put them inside the cubic root. My perfect cubes here, okay. Sorry. I'm going to pick a number that's smaller than 81, like 64. And then the next number that's bigger than 81 is 125. And then I know that 64 is 1, 2, 3, 4. So this is 4. And then 5. So that means this number here is between these two things. I would write it, but it's really messy. So I would write that inside there. And that's how you can figure it out. Now, when I get to number 4, think about it. One perfect cube you might know is 1,000. So what number is 1,000? What is the cubic root? What is the cubic root of 1,000? I'll let you think about that. And then you can answer number 4. And then finally, you just have a couple problems to consider, and then you're going to put them where you're putting them on the number line. So if you know that x cubed is 5, then, and we just talked about how the cubic root of 5, that's one of the first ones we did, was somewhere between, take the cubic root of this. So to find x, I would take the cubic root of 5, and we know that was between 1 and 2. So do I think it's closer to 1 or closer to 2? Well, it's probably closer to 2. So it would probably be somewhere around here. So I'm going to put x here. And then 27, well, that is a perfect cube. That would be, if I take the cube root of both sides, I would get 3. So y would go here. And then you can think about 700. Where would that go? If I have negative, well, that's going to be a negative answer. And that's going to be probably right about here. Right, that's going to be my last one. Okay, so hopefully this gave you some things to consider. You can complete the practice then and practice your square